Hello grade 10s. Today we're going to be going through linear, quadratic and simultaneous equations. Now all of these you have the skills to do. You've learned them from grade up, right up until now, but now we're going to be applying things in a new situation. So we're going to start with some revision and then move on to some questions. Now the first thing we're going to revise is linear equations. Linear equations do not have any exponents, so it'll be in the form of x plus 2 is equals to 3. If it had a squared there or a cubed, it would not be a linear equation. So x plus 2 is equals to 3. You've been learning these since grade 8, and the way you would tackle them is you would need to get rid of the 2 by minusing 2 from this side, and of course I'm sure you've heard your teachers say whatever you do to the one side, you do to the other side as well. This would give you an answer of x is equals to 1. Now of course you are no longer in grade 8, so you're not going to show all of those calculations. You're rather going to say, start with x plus 2 is equals to 3, and then you're going to show that you have subtracted it from the other side. So minus 2. And then finally, you're going to get your answer of x is equals to 1. Because we're in grade 10, things have changed slightly. We're now working with fractions, and fractions, you then have a different set of rules. You've got to find a lowest common denominator, and once you find the lowest common denominator, you've then got to change everything to the lowest common denominator and then get rid of the denominator. It makes working with fractions so much easier. But remember that you can only do this when you are working with an equation. So there has to be an equal sign for you to get rid of the denominators. If it is an expression, in other words, if there's no equal sign, you can't get rid of the denominator. Let's do an example with a fraction. So we have the equation 2 over x plus 4 is equals to 12 over 2x. Now 4 is the only number over here without a denominator, so I'm going to put it over the denominator of 1. Remember, all whole numbers have a denominator of 1. Our denominators are therefore x, 1 and 2x. Remember, the lowest common denominator is something that everything can go into. So can 1 turn into x? Yes, if we multiply 1 by x, we're going to get x. Can 2x become x? No, but x can become 2x by multiplying x by 2. So our lowest common denominator is going to be 2x. And we're going to change this all in one step very quickly. How does x become 2x? We multiply it by 2. And because we are changing the bottom of the fraction, we need to change the top as well so that we don't change the value of the fraction. In other words, we're making an equivalent fraction to 2 over x to suit our needs. Okay, how does 1 become 2x? We multiply it by 2x, and of course, because we're changing the bottom, we need to change the top as well by the same amount. And do we need to change the denominator on the other side of the equals? No, because it's 2x already, it'll be fine. So let's do all of those changes. 2 times 2 is equals to 4 over 2x. 4 times 2x gives us 8x over 2x. And 12 over 2x stays 12 over 2x. Now I'm going to put everything over one denominator just to make it easier to work with. In other words, we're adding those two terms. Because they are not like terms, we can't add the values, but we can show that they are still being added. So 4 plus 8x over 2x is equals to 12 over 2x. Now the mathematical way to get rid of that 2x on both sides is to multiply both sides of the equation by 2x. And you remember earlier on we were talking about what you do to the one side, you have to do to the other side. And this is so that you don't change the value of the equation. Because you are multiplying both sides by 2x, the denominators actually just fall away. So often what you'll find in your calculations is you will go straight from that step onto this step over here, just writing 4 plus 8x is equals to 12. Now it looks like something you've seen in grade 8. So now let's solve. We don't want the 4 on this side because we want to isolate the x, and we move the 4 across by minusing both sides by 4. And now what we have is 8x is equals to 8. How do we get rid of that 8 in front of it? Because it is multiplying over here, we need to divide both sides by 8. And remember this pink stuff, you don't actually have to show those calculations. It's just a teaching technique for me. So what we have is x is equals to 8 over 8. And for those of you who are feeling more confident, you would have been able to skip straight to x is equals to 1. Okay, the next thing we need to point out is when you have a variable in the denominator, you need to point out what the limits are. The limits for this is x cannot equal 0. Now why can x not equal 0? Because if x did equal 0, then these fractions would be unreal. We only work with real numbers. Now, you might be getting quite bored of linear equations. You've been doing them since grade 8. So what we do is we combine these skills with other skills that you will have to know. And you will have to apply linear equations when you do quadratic equations, simultaneous equations, even with some graphing work. When you go into grade 11 and you start doing linear programming, you will have to do that as well. We will now go on to quadratic equations. Okay, quadratic equations are when you have an x squared. Remember, squared is like a quad, so that's what gives you the clue. So quad, squared, that's how you know that you have to do quadratic equations. In order to solve a quadratic equation, you are going to need to factorize. So whenever you see a squared, you know you need to factorize. And once you have factorized, you'll find that you'll have two different answers at the end of it. This is normal. Sometimes your two different answers do equal the same number, and that's okay as well. Personally, I like to do a step-by-step method when doing quadratic equations, and I'm going to write that down for you now. Step 1 is to make everything equal to 0. What that means is you are going to move everything over to one side and have 0 on the other side. Once you have done that, you can move on to the next step. If you find that you do move everything over to 0 and you no longer have an x squared, it means that you have a linear equation. And then you can apply laws of linear equations. Step 2 is to factorize. Now there are 4 different types of factorizing you know by now. And there's a definite order that you can do it in. In other words, you always look for a common factor first. If you can't find a common factor, then you look for a difference of 2 squares. Difference of 2 squares. It's a beautiful looking square. Then you look for a trinomial. If you can't find a difference of 2 squares, you have a trinomial. And lastly, you will look for a sum or difference of 2 cubes. Now remember, there's a definite formula for doing the sum or difference of 2 cubes. If it is x cubed plus y cubed, you will get an answer of x plus y, x squared minus xy plus y squared. So that's the sum of two cubes. If it's the difference of two cubes, it means it has a minus between them. And your first bracket will be x minus y. Your second bracket will be x squared plus xy plus y squared. Okay. All of those factorizing you should know from a previous lesson. So you should be revising your factorizing with your expressions and then moving on to these equations. If you can't factorize yet, you need to go back and practice until you can get it right. Trinomials are particularly important and take a lot of practice to get right. So go over it until you can do it. Let's move on to step 3. Now step 3 is to divide the factors of the equation up and make each one equal to 0. Once you have done that, you'll find you have linear equations. So then you can solve for your variable. Okay. There are quadratic equations in 3 easy steps. So step 1, make sure everything equals to 0. Step 2 is factorize, and remember there are 4 subparts to factorizing. There's finding a common factor, there's the difference of two squares, there's a trinomial, and there's a difference or sum of two cubes. Then lastly, you need to separate the two factors, make them both equal to 0, and solve for it as a linear equation. The reason we separate both factors is because the word factors implies that they are multiplied together. And we know that anything multiplied by 0 is equals to 0. So if either one of those factors were equal to 0, then the equation would be true. And that is how we get our two values for our variable. Let's move on to some examples. Okay, now what we have here is 2k plus 3 is equals to 2 minus 3 in brackets k plus 3. Let's start by multiplying out the brackets. Remember, if you don't do BODMAS, you don't pass. So you must always do brackets, divide, multiply, add, and subtract. Okay, so 2k plus 3 is equals to 2 minus 3k, because that multiplied by that is minus 3k, and then minus 3 times by 3 is going to give us minus 9. Remember that that is called distributive law, when we multiply a term that's on the outside of the brackets by all of the terms on the inside of the brackets. Now let's simplify both sides as much as we can. 2k plus 3, neither one of those terms can be added together, so we just leave them like that. But now we have 2 and minus 9. So I'm going to put minus 3k in the front and add 2 and minus 9 to get minus 7. The next step is now to isolate the variable. So what we need to do is take the 3k from where it is and put it with the 2k. The way we do this is we add 3k to both sides of the equation. That way the minus 3k disappears from the right and we have 2k plus 3k on the left. Now we also at the same time want to get rid of the plus 3 on the left. So we're going to minus 3 from both sides. As you know, 3 minus 3 gives us 0, so I'm not going to write it on the left, but I will write minus 3 on the right. The next step is to then add our like terms. So 2k plus 3k. I've got 2k's and I'm adding 3k's to them, which means I've got 5k's. And then on the other side, I've got minus 7, minus 3. Now, I've got minus 7 and I'm taking away another 3, which means I'm left with minus 10. How do I get rid of the k now? Oh, sorry, how do I get rid of the 5? Well, the 5 is multiplying the k. So that means if I want to get rid of the 5, I need to divide both sides of the equation by k. You're not going to show it as in detail as you did when you were in grade 8. What you're going to show is just k is equals to minus 10 divided by 5, which means that k is equals to minus 2. Now, it is possible to do this in fewer steps. However, I find people who skip steps often make stupid mistakes. Let's move on to the next question. Moving on to question 2. Now, in question 2, we have a binomial times by a binomial. For this, you're going to use FOIL, which you learnt in grade 9. The next part, minus d, we're not going to do anything with just now, but later on we will add it into the equation. This doesn't mean that you mustn't write it down. You must have it written in every line until you use it. Then we have a squared binomial. There is a shorter method to deal with a squared binomial. I find most people get it wrong, and therefore I recommend that you go back to doing FOIL for when you are squaring binomials. And lastly, we have minus d into d minus 1, which means that we're going to be using distributive law. Now, all of these have to be done in the BODMAS order. So you must always start with brackets first and then do the rest. Let's start with the binomial times binomial in the first one. We've got first times first, which is going to be d times d, and that is d squared. Then we've got the outside terms multiplied together, which is d times negative 3, which is negative 3d. Inside terms multiplied together is going to be 4 times d, which is 4d. And your last terms are going to be the last term in each bracket. So it's going to be 4 times minus 3, which gives us minus 12. Now remember, just because you've done FOIL over here doesn't mean you mustn't write down the minus d. You must have everything that is in the top line in the next line as well. Okay, now we've got a binomial squared. I'm going to rewrite it so that in the next line of calculations I can do FOIL with it. Having it rewritten just makes it easier not to make mistakes. So all I've done is I've rewritten the brackets twice, and now I've got minus 8d times d, because distributive law says whatever's on the outside of the bracket you must multiply in, gives us minus 8d squared, and minus 8d times minus 1 gives us plus 8d. Okay, now on the left-hand side we have multiplied out all of the brackets, and we can now add the like terms. So let's start with the d squareds. There is only one d squared on the left-hand side, so I'm just going to write it down. In terms of the d's, we have minus 3d, plus 4d, and minus d, which means we have no d's left, leaving us just with minus 12. So we've got d squared minus 12 on the left-hand side. On the right-hand side, we still need to do FOIL. So we're going to start with first times first. 3d times 3d gives us 9d squared. 3d times negative 22 for our outside gives us negative 66d. Negative 22 times 3d for the inside gives us negative 66d. And lastly, negative 22 times negative 22 gives us positive, not positive 44. Let's work it out on the calculator quickly. 22 times 22 gives us 484. Now you might be wondering why I didn't put the negatives in front of it. you'll see over here, negative 22 times negative 22 gives us positive 484. I know that a negative times a negative will give us a positive, so there we go. Plus 484. Minus 8d squared plus 8d. Okay, we have simplified the left-hand side. We still need to simplify the right-hand side, so for the moment I'm going to leave the left-hand side as it is and just rewrite it in the next line. Okay, now the right-hand side. I'm going to indicate our like terms. We've got 9d squared and we've got minus 8d squared. If we add those together, we have d squared. Next, we've got minus 66d, minus 66d, and plus 8d. Going to use the calculator to work this out. Minus 66 minus 66 plus 8 gives me minus 124d. So minus 124d. And lastly, we're left with plus 484. Okay, at the moment it looks like it will be a quadratic equation because we've got d squared on both sides. So what I'm going to do is move everything to one side and see what happens. Remember previously I rearranged them as I was moving them over. So I'm keeping that d squared on the left-hand side in the front. Then from the right I'm going to minus d squared. And those of you who are thinking ahead can see that the d squareds are going to cancel out, leaving us with the linear equation. Moving on. That is minus 124d. Because it is minusing on the right-hand side, we are going to add it on both sides, giving us plus 124d. And then lastly, we are adding 484, which means we're going to have to minus it to get rid of it. So when I move it over, I'm minusing it. And the minus 12 goes over there. Okay, d squared minus d squared gives us nothing. So now we're left with 124d minus, and let's use the calculator, 484 minus 484 minus 12 gives us minus 496. 496 is equals to 0. Because it is a linear equation, we can now move the 496 to the other side. It was adding and minusing on the left-hand side, so in order to get it away from the d, we've got to add it on both sides, making it 124d is equals to 496. What is the 124 doing to the d? It's multiplying. So how are we going to separate it from the d? We're going to divide both sides by 124. So that means d will be equal to 496 divided by 124, and I need a calculator to work that out. 496 divided by 124 gives us an answer of 4. So that means our final answer is d is equals to 4. So let's go over that again very quickly. It was a very complicated looking problem, and it tested whether you knew FOIL and distributive law. Then it tested that you could add like terms and you could rearrange your equations so that you could isolate the variable, ending up with the number 4. Let's move on to the next question. In this question, we've got m plus 6 into brackets minus m plus 1 plus 5m is equals to 0. Now, because I've done so many of these, I know it's going to be a linear equation. I can see that there's no m times m. So I'm just going to jump straight into it by doing distributive law first. the m I'm going to leave over there, minus 6m. How did 6 become minus 6m? 6 times minus m gives us minus 6m. And 6 times 1 is going to give us plus 1, plus 5m. Now that we've multiplied out our brackets, we can now add our like terms. So I've got m minus 6m plus 5m. Oh dear. Well, that gives us 6 is equals to 0. Does that work? No, it doesn't. So we say, therefore, there are no real solutions. There is no way that 6 will ever equal 0. It's good to know this. If your variables ever do disappear completely and you are left with a number is equals to 0, you don't have any real solutions for m. So there's no way this equation does work. Let's move on to the next one. Question 4. We have 5t minus 1 is equals to t squared minus, and then we've got a binomial times by a binomial. So the first thing you're going to do is to do FOIL. Everything else for now I'm going to leave as it is and just focus on the FOIL. So 5t minus 1 stays as it is. T squared I'm not doing anything with. And in brackets I'm going to multiply out. T times t, because that's our first, is t squared. Our outside is t times minus 2, which is minus 2t. Our inside is 2 times t, which is plus 2t. And our last is 2 times minus 2, which is minus 4. Now, if you had looked a little closer in the beginning, you would notice that those brackets are the result of a difference of two squares. And the difference of two squares that would result in that would be t squared minus 4. And you're going to see that happen over here. You'll also notice I've kept the answer in brackets, and the reason I've done that is because we've got a minus in front of the brackets. And that minus, once you have finished multiplying out the brackets, will then be multiplied in using distributive law. Let's carry on with what's in the brackets to see if it ends up as t squared minus 4. So 5t minus 1 we're not doing anything with at the moment. And we have t squared minus, and then inside the brackets we've only got 1t squared, so I'm going to leave it as it is. Then minus 2t plus t gives us no t's, minus 4. If you did notice that t plus 2, t minus 2 was the result of t squared minus 4, you could jump straight to the second step, so you wouldn't have to show your calculations. However, once again, people who skip steps usually get things wrong, so watch out for it. Now let's multiply out the brackets using distributive law. Still, 5t minus 1 gets written down. T squared still gets written down, and now we have minus t squared, and it became minus t squared because minus times positive t squared gives us minus t squared, and minus times negative 4 gives us plus 4. Let's simplify both sides. 5t minus 1 is simplified as much as possible. And on the right side, t squared minus t squared is nothing, so we're left with 4. Well, now it's a lot easier to solve. Now it looks like something you would have received in grade 8. We're going to start by taking the negative 1 to the right-hand side, and the way we do this is we add 1 to both sides. We now have 5t is equals to 4 plus 1, which means that 5t is equals to 5. The last step is to get rid of the 5, and what is it doing to the t? It's multiplying. So if we wanted to get rid of the 5, we would have to divide both sides by 5, meaning t would be equal to 5 divided by 5, which means that t is equals to what? Let's do the next question. Okay, here we have a question that has m in the denominator. Now what this means is we have to write down what the limits are. Denominator. So our limits are going to be m cannot equal 0. Why can't it equal 0? Well, if it were equal to 0, then what we'd have would be unreal numbers. And that wouldn't suit us. We only work with real numbers in mathematics. Let's move on. Now, the next thing we need to do is to find a lowest common denominator. If 5 is over 1, and the other two fractions are over m, our lowest common denominator is going to be m. So what we need to do is change 5 over 1 to 5m over m. How did that happen? Well, in order to change 1 to m, we've got to multiply the 1 by m. And because we've changed the bottom of the fraction, we need to change the top of the fraction so that we don't change the value of it. So we have an equivalent fraction to 5 over 1 is 5m divided by m. The rest of the question remains the same, minus 2m plus 4 over m is equals to 7 over m. The next thing I'm going to do is just put everything over one denominator. So on the left-hand side, rather than having 5m over m separate from everything else, I'll put a long line down and have it all over m. Now I have 5m minus 2 in brackets m plus 4 is equals to 7m. You'll notice that I haven't multiplied out the brackets yet. Now the reason I haven't done that is because this minus needs to be multiplied into the brackets as well. And often that gets confusing when you're trying to deal with the denominator and then trying to do the brackets as well. It's best just to do one thing at a time. Let's now multiply both sides by m to get rid of that denominator. You would not have to show this, the multiply by m. You could actually, in the next line, just write down 5m minus 2 into brackets m plus 4 is equals to 7. And the reason that happened is because we multiplied both sides by m, we were able to drop the denominator, so m cancels with m cancels with m, and we were left with that equation. Now that equation looks like something you would have gotten in grade 9 because it has distributive law in it. Let's do the distributive law. Minus 2 times by m gives us minus 2m, and minus 2 times by 4 gives us minus 8 is equals to 7. Okay, now that we've multiplied out the brackets, let's simplify both sides by adding the like terms. 5m minus 2m gives us 3m minus 8, and the 8 didn't change because it didn't have any like terms on the left-hand side. And on the right-hand side, we've just got 7, so it stays 7. We now need to isolate the m, and we do this by first getting rid of what's being added and subtracted. Over here we've got minus 8, so we need to get rid of it by adding 8 to both sides of the equation. You don't show that step, you just show that 3m is equals to 7 plus 8, which of course is 15. And the next step is to get rid of the 3 in front of the m. What is the 3 doing to the m? 3 is multiplying the m. So the way we get rid of the 3 is to divide both sides by 3. You don't write that we've divided both sides by 3. You just need to write that 15 is divided by 3, and that 3 will have disappeared. Now 15 divided by 3 gives us 5. And there we go. We've started at the top with fractions. We've defined our limits. Was m equal to 0? No, it wasn't. It means that it is a real answer. If m had equaled 0, then we would have said there would be no real solution. Then we found our lowest common denominator and got rid of the denominator, used distributive law, added our like terms, and then found out what m was equals to. We're now going to cut to a short break so that you can get up, drink some water, and get ready for the next questions. See you just now. Hello grade 10s, I hope you're feeling refreshed, and now we can start with our next question. Now we'll see that question 6 does have some fractions in, but it also has brackets in as well. So I'm first going to deal with the brackets and then try and find the lowest common denominator and get rid of the denominator, so on and so forth. On the left hand side, I do have some like terms I could add, but before I add them, I'm going to change our whole number to an improper fraction and then change it to over 2, which makes it 2 over t minus 4 over 2 minus 1 over 2. And on the right hand side, I'm going to multiply. Now remember, fractions are our friends, and when we multiply fractions, it's like they are hugging each other. 1 over 2 multiplied by 1 over 1 means that it's going to be 1 times 1, which is 1, and 2 times 1, because you multiply the top by the top and the bottom by the bottom. And so 1 over 2 times by 1 over 1 gives us an answer of 1 over 2. 1 over 2 times by 2 over t is going to give us an answer of 1 times 1 is 2, and then 2 times t is going to be 2t. Let's simplify as much as we can before we find our lowest common denominator. So we have 2 over t minus 5 over 2 is equals to 1 over 2 plus 2 over t, 2t. Now that we've done that, we need to define two things. Firstly, what are our limits? And the only reason we find our limits is because t is in the denominator, and that means we need to find the numbers that t cannot be so that our equation remains real. We can never divide by 0, which means that t mustn't be 0. The next thing we need to find is our lowest common denominator, and remember, we find that by finding out what each number can become through either multiplication or division. 2t seems to be our highest number. 2 can become 2t by multiplying it by t, and t can become 2t by multiplying it by 2. So by default, our lowest common denominator is 2t. I'm now going to change all of the denominators to 2t by multiplying them by what they need to be multiplied by. So t needs to be multiplied by 2 to become 2t, and remember, we can't change the value of the fraction, so I need to multiply the numerator by 2 as well. In minus 5 over 2, I need to change the 2 to 2t, meaning I must multiply the 2 by t, and so that I don't change the value of the fraction, I need to multiply the numerator by the same amount. The same thing is happening on the other side. With 1 over 2, it becomes t over 2t. In the next line, you would write this all down. Now, it's not essential for you to write down all the pink. However, I find that most people who try and skip that step do get it wrong, and so if you're not confident, I would recommend you write it down. So t over 2t plus 2 over 2t. Before I try and get rid of any denominators, I'm going to simplify it by putting them all over one denominator on each side. So everything over 2t on the left-hand side becomes 4 minus 5t, and on the right-hand side, t plus 2 over 2t. Now remember that you don't need to show that you are multiplying both sides by 2t. But because I am a great teacher, I'm showing you how to do it. 2t will then cancel with 2t. And because we've changed the equation on both sides, it remains the same value. So we've multiplied by 2t on both sides, keeping the equation the same value. And we now have 4 minus 5t is equals to t plus plus 2. And now it looks a lot more like something you've seen in grade 8 and grade 9. It's far easier to solve. We know it's a linear equation because t is not squared, so that means we need to isolate the variables and we need to have the numbers on the other side. I'm going to start by isolating the t's on the left-hand side, so I've got minus 5t, and then the t on the right-hand side, I'm going to minus t from both sides, leaving me with minus 5t minus t is equals to 2, and to move the 4 to the right, I'm going to minus, and remember I've done that by minusing 4 from both sides. It's because 4 is being added on the left-hand side that I need to minus them from both sides. Now let's simplify by adding like terms. Minus 5t minus t gives me minus 6t, and then 2 minus 4 gives me minus 2, and now I have minus 6t is equals to minus 2. How do I get rid of that minus 6t? And this often confuses people because usually if it was just 6t, they would know 6t is equals to 2. You would divide both sides by 6 and you would get an answer of t is equals to 1 over 3. But because of the minus, they get confused. There's no reason to get confused. You always look at what it is doing. For instance, the 4 on the left-hand side, 2 steps up, was adding. And so to get rid of it, we had to minus. Now the minus 6 is multiplying, so in order to get rid of it, we need to divide. So it's not what it is that's important, it's what it's doing. And that's a really good life skill. It's not who you are, it's what you do that's important in life. So the minus 6 multiplied by t becomes t is equals to minus 2 divided by minus 6, which gives us t is equals to 1 over 3. And there we go. Let's move on to the next question. And now we come to our quadratic equations. How do I know this? Because I have an x squared, and there is no hope of that squared disappearing unless I factorize. So as soon as you see the squared on a variable, you know you need to factorize in some way. What were those 4 different skills you could use to factorize? There was finding a common factor. There was a difference of 2 squares. There was a trinomial. And lastly, there was a sum or difference of 2 cubes. So those are the 4 things you need to look for, and in the order you need to look for them in. So the first thing you always look for when you're doing step 2 is first a common factor. Then you look for a difference of 2 squares, then you do a trinomial, and you do a sum of difference or difference of 2 cubes. Remember, your common factor also includes grouping and changing the sign. Change of sign. Okay. Over here, step 1 is to make it equal to 0. Is it equal to 0? Yes. Step 1 is complete. Step 2 was to factorize. How can we factorize it? Let's look for a common factor. We have x squared and we have minus 3x and we have 2. The x is not common in all 3 of them. X squared does not have a numerical coefficient, so there are therefore no numbers that can be taken out from it. So therefore, we don't have any common factors. Next, we are going to look for a difference of 2 squares. Now, a difference of 2 squares means we have one squared number minus another squared number. X squared is a squared number, minus 3x is not a squared number, and plus 2 is also not a squared number, so we don't have a difference of 2 squares. The third one, and most of you would have realized it's a trinomial immediately, is what it is. How do we recognize a trinomial? It has 3 terms. Once it has been simplified, it has 3 terms. In other words, once you've added all the x squareds together, all of the x's and all of the numbers together, you're left with just 3 terms. One of them being a variable that's squared, one of them being a variable, and the other one being a number. You will have done various methods for trinomials. Personally, I prefer this method using the cross, where you divide the factors of the equation up, or you divide the different terms into their factors. So I've rewritten the question over here to suit my method. In your calculations, it is nice to have a little scribble patch on the right-hand side of your page where you can then scribble this down. Over here, all we want to see is the brackets with the answers. We're not interested in how many times you tried it, although if you have how many times you've tried it on the right-hand side of the page, maybe you can get some marks for it. Now the first thing we need to do is divide x squared into two different factors, which are going to be x and x. In other words, x times x is equals to x squared. The next thing we're going to do is divide 2 into two factors. So what are two numbers that when you multiply them together become 2? 2, it's nice and easy. It's only 2 times 1 gives us 2. Now we're going to multiply across these lines. So x times 1 is equals to 1x. And 2 times x is equals to 2x. Now 2x plus 1x equals 3x. Now the whole point of this is to try and get this answer over here to be the same as the middle term. Is it the same? No, it isn't. We have positive 3x as our final answer when we've added those two together, and we want minus 3x as our final answer. So how can we change these values that are in our calculations? We know that 2 times 1 is equals to 2, but also, and let's do this in green, negative 2 times negative 1 will give us positive 2, because a negative times a negative gives us a positive. Now if we factor that into the question, x times by negative 1 gives us negative 1x, and negative 2 times by x gives us negative 2x. Negative 2x plus negative 1x gives us an answer of negative 3x. Now you see why you need your calculations on the right. It's because it does get confusing for teachers to look. And there we go. That is the same as what's happening up there. So our brackets are going to be x minus 2 and x minus 1. So x minus 2 is in our first brackets and x minus 1. Okay, can we factorize it anymore? There are no more common factors, there isn't a difference of two squares, there's no more trinomial, and there's definitely no sum or difference of two cubes. Remember, you would have a cubed variable if there was sum of difference of two cubes. So we have finished step 2. Now step 3 is to then divide the two factors of the equation into two separate parts and make them both equal to 0. So we have x minus 2 is equals to 0, and x minus 1 is equals to 0. The reason we've done this is because 0 multiplied by anything is going to give you an answer of 0. So if x minus 2 is equals to 0, it means that when you multiply x minus 1 by it, you will get an answer of 0, making the equation true. The same way, if x minus 1 had a value of 0, then 0 times x minus 2 is going to give you 0, so it would make it true as well. Let's solve for these two equations separately. X minus 2 is equals to 0 is going to be x is equals to 2. And over here, x minus 1 is equals to 0 becomes x is equals to 1. So our two answers are x is equals to 2 or x is equals to 1. Because we have x squared, it means that we will have two answers for x. Sometimes these answers are the same value, but most of the time they are different values. Let's move on to the next question. Okay, question 8 has 0 is equals to 2x squared minus 5x minus 18. The x squared shows me that it is a quadratic equation, and that means I've got 3 steps I want to follow. Step 1 is to make it equal to 0. Is it equal to 0? Yes, it is. Step 2 is to factorize. Well, I'm going to start by looking for a common factor. Is there a common factor? No common factor. 2 and 5 and 18 don't have a common factor, and not all of the terms have an x, so nothing happening there. The next thing I look for is a difference of two squares. There are no squared numbers over here. Yes, x is squared, but the 2 as a coefficient means that it is not a squared number. So no difference of two squares. Next thing I look for is a trinomial. Do I have 3 terms? Yes, I do. Do I have an x squared and an x and a number? Yes, I do. So now I'm going to start the trinomial. And remember, I'm doing it on the side. 2x squared minus 5x minus 18. And this is just so that I can show my calculations somewhere where they won't distract from the real question. Okay, what are 2 factors of 2x squared? It's pretty easy. 2x times by x will give us 2x squared. What are 2 factors of 18? How about 9 and 2? Now you'll see for the moment I have ignored the minus, and the reason is because sometimes the minus is easier to add in after you've multiplied these things out. So I'm now going to multiply them out and then see if a minus will help us. 2x times by 2 gives us 4x, and 9 times by x gives us 9x. Now keeping in mind that one of these numbers are going to be negative, is it possible to make negative 5x from these answers? Yes, it is. If I make the 9 negative, so negative 9 times 2 gives us negative 18. That means that negative 9 times by x will give me negative 9x. Negative 9x plus 4x will give me 5x. Negative 5x. Is negative 5x the same as the middle term? Yes, it is. It means that my brackets are going to be 2x minus 9 and x plus 2. So in the next line of this question, I'm going to write 0 is equals to 2x minus 9 and x plus 2. Remember, if there's nothing in front of the 2, then it's obviously a positive, which means you're going to be adding it. Okay, now that I've got that far, I have finished step 2, I now need to do step 3. And step 3 is when we separate the 2 factors of the equation and we make each one equal to 0 independently. Remember that the reason we do this is so that is because anything multiplied by 0 is equals to 0. So if 2x minus 9 has a value of 0, it means that when it multiplies x plus 2, it will get an answer of 0. Let's find out what our first value for x is going to be. We're going to start by moving the 9. It is being minused over here, which means we're going to add it to both sides, meaning we have 2x is equals to 9. And lastly, we need to get rid of the 2. Remember, the 2 is multiplying x, so in order to get rid of it, we need to divide both sides by 2. So our first answer for x is going to be x is equals to 4.5. Personally, I prefer it when it's left as 9 over 2. It just makes it easier to work with later if I do need to work with it later. However, we don't need to work with it later, so I've just put in 4.5. This factor is far easier to work out. X plus 2 is equals to 0 becomes x is equals to negative 2. So just to write it neatly, for your teacher in your last line you can say therefore x is equals to 4.5 or x is equals to negative 2. And there we go. Let's move on to the next question. Okay, what tells me that this is a quadratic equation? If you said that t was squared, then you're correct. Now we've got 3 steps to doing a quadratic equation. Step 1 is to make everything equal to 0. So we're going to start by saying t squared minus 3t is equals to 0. How did the 3t move? Well, we're adding 3t on this side, which means in order to get to the other side, we have to minus 3t from both sides. So we have t squared minus 3t is equals to 0. Is it equals to 0? Yes, so we've completed step 1. Step 2 is to factorize. And what's the first thing we look for? A common factor. T squared and 3t have a common factor of t, so that's actually quite nice and easy. Take out t as a common factor, and what are you left with of the first term? Well, t squared divided by t leaves you with just 1t. If you want to check it later, what you need to do is go t times t will give you t squared. Over here, minus 3t divided by t gives us minus t. Minus 3. If you want to check it, t times minus 3 gives us minus 3t. And that's all equal to 0. Can we factorize it any further? I don't see any possibilities of that happening. Once the squared has disappeared, it's pretty much been factorized as much as possible. So we have finished step 2. Step 3 is to divide the parts of the equation up into 2 separate parts and make them each equal to 0. So t is going to equal 0, and t minus 3 will equal to 0. Do we need to continue with t is equals to 0? No, it's already given us our answer over there. We do need to find the value for t in the other case. So t is equals to 3, and there are our 2 answers. T is equals to 0 or t is equals to 3. Remember, making your work easy to read means that you will get better marks, because a happy teacher is a teacher who gives more marks. Let's move on to the next question. Okay, what tells us that this is a quadratic equation? I hope by now you're all spotting the x squared, because that tells us it's a quadratic equation, and because of that we need to factorize. Before we factorize, we need to start with step 1. And step 1 is to make everything equal to 0. So I'm going to start by moving the 12 over to this side. And I've done that by subtracting 12 from both sides of the equation. 12 minus 12 gives us 0 on this side, and we just write the 12. Is it equals to 0? Yes, it is, so step 1 is complete. Step 2 is now to look at it for the factorizing. Do we have a common factor? Well, 2x squared minus 2x minus 12. What's common in all of those? And I hope you spotted that it was the number 2. 2x squared divided by 2 gives us x squared. Minus 2x divided by 2 gives us minus x. Minus 12 divided by 2 gives us minus 6 is equals to 0. Have we finished factorizing? No, we've still got an x squared, but what we have done is made it easier to deal with all of our variables. There's something quite sneaky you can do right now, and that is you can get rid of the 2 by dividing both sides of the equation by 2. And that means that you are left with x squared minus x minus 6 is equals to 0. How did that happen? Well, I'm going to show you on the side just very quickly. In order to get rid of the 2, we divide both sides by 2. The 2 cancels with the 2, and over here 0 divided by 2 is equals to nothing. So x squared minus x minus 6 is equals to 0. We haven't finished factorizing. We've taken out the common factor. Is there a difference of 2 squares? No, there isn't. X squared is a squared number, but minus x isn't and minus 6 isn't. The next thing we look at is a trinomial. Are there 3 terms? Yes, there are. One of them is an x squared, one of them is an x, and one of them is a number. So the trinomial is going to work great here. Once again, I do my calculations on the side. First rewrite the trinomial, and then I draw the x. Now you'll notice how the x lines up so that I know that x squared, the factors of x squared, go down on the left, and the factors of -6 go down on the right. What are two factors of x squared? X and x. And what are two factors of -6? Well, they're going to be 3 and 2, and one of them will be negative. But for now, I'm going to leave that and add it in just now. X times 2 gives us 2x, and 3 times x gives us 3x. How can these two be put together if one of them is negative to make the final answer of -x? Well, that's quite easy to see now, because if 2x were negative, then our answer would be x. But if 3x were negative, then our answer would be -x, because -3x plus 2x gives us -x. So that means our brackets are going to be x minus 3 and x plus 2. When you first start doing quadratic equations or any kind of trinomials, it takes quite a lot of practice to see the factors immediately. And often you'll have to do the same question 3 or 4 times. The trick is to not give up. With every attempt you do, you get closer to finding the answer because you have found what the answer isn't. So eventually you're going to run out of options and you will find the right answer. Okay. Now that we have factorized completely, how do I know we factorized completely? I've got no more x squareds. So now that it has been factorized completely and we have completed step 2, let's move on to step 3, when we divide the factors into 2 separate parts and make each one equal to 0. And remember, the reason behind this is whatever is multiplied by 0 will give an answer of 0. So if either one of these factors are equal to 0, you will get the right answer. X minus 3 is equals to 0 becomes x is equals to 3. And x plus 2 is equals to 0, x is equals to -2. So there's your answer. Therefore, x is equals to -3 or x is equals to -2. So to revise on how we did that, we first took out a common factor, then we did a trinomial, and then we were able to get an answer. Now, in truth, most people will not see that common factor first, and it makes the question a lot more difficult for them. So I'm going to show you how to deal with that if that happens. The question is, and let's do it in a different color, 2x squared minus 2x, and it was equals to 12. Now everyone will get the first step right, and that is making it all equal to 0. And then, because everyone thinks they are more clever than they actually are, they'll skip past common factor because they can see immediately that it's going to be a trinomial. You can do a trinomial with the values that are here. It just makes it a lot more difficult to find the factors. If you take out a common factor first, it's easier to see what's, you have less options with your factors of what's multiplied by what. And eventually you will have to take out a common factor. So rather take it out in the beginning. What are two factors of 2x squared? Well, we've got 2x and x. And what are two factors of 12? Let's start with 4 and 3. 2x times by 3 gives us 6x. And 4 times x gives us 4x. Now, is it possible to put these together so that they make -2x? Not at the moment, but keep in mind that it's -12 that we were meant to have here. And 4 times 3 is equals to +12. So that means either 4 or 3 are going to be positive. Which one, are going to be negative. Which one would suit us to be negative? -6. So that means 2x times by -3 will give us -6x, and 4x minus 6x will give us an answer of minus 2x. That means our brackets are going to be 2x plus 4 and x minus 3. Now you get to this point and you must look at it again and say, have I factorized it? And the truth is, it is factorized. You don't have any more x squareds in it. However, if you are looking for it, you will see that you have a common factor in the first bracket. And it is possible to take out that common factor over there. So 2 is the common factor in the first bracket, meaning that it's going to be 2 into x plus 2. And then over here, that stays the same. We don't have to take out the common we don't have to take out the common factor from the second bracket because it's all multiplied together in the end anyway. And there we go. Then you will get the same answers of x is equals to negative 2 and x is equals to positive 3. Or at least, let's correct that. X is equals to positive 3. Now, the reason I say it can go wrong is because our factors for 12 are 1 times 12 is equals to 12, 2 times 6 is equals to 12, and 3 times 4 is equals to 12. So there you have 3 different combinations that could work for that last part of the bracket. For 6, it's only 2 combinations. You've got 6 times 1 is equals to 12 to 6, and 2 times 3 is equals to 6. It's far easier to do it if you have taken out a common factor in the beginning of 2. So watch out for that. Now I know some of you are wondering, what if I went straight from that step to x is equals to minus 2 and x is equals to 3. The problem with taking out this common factor is that there is a mark allocated to it. So in order to get full marks, you need to take out the common factor. You must take out the common factor. Always look for it. If this question was out of 4, you would have got 3 if you had skipped straight to finding out what x is equals to. Remember, in maths, we're no longer just looking for the answer. We're looking that you have the skills. You can see a problem. You can see how to tackle a problem. And you can do the tackling of the problem as well. The answers just happen as a result of all of those skills. Let's move on to the next question. Okay, how do I know that this is a quadratic equation? Well, I have an x squared. And that means step 1 is to make all of it equal to 0. So bring everything to one side. Why have I put the 12x in the middle? Because I like to have things in orders of degrees. In other words, the x squared, then the x, then the number. It makes things far easier later on when I'm doing the factorizing. So I have 3x squared minus 12x minus 63. How did the 12x come to be there? Well, in order to move it from one side, I've got to subtract 12x from both sides. 12x minus 12x gives me nothing. And on the other side, the 12x remains. What is step 2? To factorize. The first thing I need to look for is a common factor. 3x squared minus 12x minus 63. What do all of those numbers have in common? 3. So I'm now left with x squared minus 4x. And what is 63 divided by 3? 21. Okay. What is that sneaky thing I can do now to get rid of the 3? Well, I divide both sides by 3, and as a result, I'm left with x squared minus 4x minus 21 is equals to 0. A far easier problem to tackle. So I've gotten rid of all my common factors. Do I have a difference of 2 squares? No, I don't. Do I have a trinomial? There's an x squared, there's an x, and there's a number. So yes, I do. On the side, I'm going to do my trinomial calculations. And I draw the x. What are two factors of x squared? X and x. And what are two factors of 21? 3 and 7. Why haven't I put the negative in yet? It's easier to put the negative in just now, when I know which will satisfy the equation better. X times 7 gives us 7x, and 3 times x gives us 3x. How can I put 3x and 7x together to get minus 4x? If 7x is negative, that means 3x plus 4x, 3x minus 7x will give us minus 4x. Just squeeze it in over there. There it is. And minus 4x is the same as the middle term, which means our two brackets are going to be x plus 3 and x minus 7. So in our brackets, x plus 3, x minus 7 is equals to 0. So we have finished step 2, which was to factorize. Step 3 is now to divide the parts of the equation up so that we can solve for each one individually. Remember, the reason we do this is because anything that is multiplied by 0 is equals to 0. So if either one of these factors are equal to 0, then it works. Let's start by getting rid of the 3, and we have x is equals to minus 3, and that's our final answer for that factor. Over here, x is going to equal 7, and there's our final answer for that factor. So therefore, those are our two answers. X is equals to negative 3 or x is equals to 7. Let's see how we could have made this really difficult for ourselves by doing it in pink. Just rewrite the question. It's 3x squared minus 63 is equals to 12x. Now the first step everyone would have gotten right by making it all equal to 0. But not everyone will look for a common factor to begin with. And that's quite overwhelming with this question. In fact, if this question were in an exam, half of your class would walk out and say, oh, that question couldn't be done, it was too difficult. I don't know why the teacher put it in, and all of that moaning that you do after exams, everyone does it. Okay, how do we, what are two factors of 3x squared? We have 3x and we have x. And what are two factors of 63? Oh, there are a lot of factors. You've got 1 times 63 gives us 63. Then you've got 3 times 21 gives us 63. Then you've got 7 times 9 gives us 63. It's just too many options. It really is. Would 1 and 63 work? No, we're looking for a middle term of negative 12, so we know that's not going to work. Would 3 and 21 work? Well, let's try it, just for argument's sake. 3x times by 3 will give us 9x, and 21 times by x will give us 21x. One of them has to be negative. Negative 21x plus 9x is going to give us negative 12x. Does it work? Surprisingly, yes. So, our brackets are going to be 3x minus 21 and x plus 3 is equals to 0. If you had done this in an exam, I can guarantee at this point you would be thinking that you had gotten it wrong, because 3x minus 21 just feels wrong. It's not. It does work. Why am I not going to get full marks for it though? Because I have not taken out a common factor. And remember, it is possible over here to take out a common factor, but you're going to lose the marks if you don't. So 3x is equals to 21 and x is equals to 7. Over here, x is equals to negative 3. The only way you can save yourself and your mark in this question is to then take out the common factor of 3 in this step, and you're left with 3x minus 7 and x plus 3 is equals to 0. If you put that in and then you go to that part, then you will get your full marks. However, I'm sure you realize by now it's far easier to look for your common factor first and then do your trinomial. Let's move on to the next question. Number 12. Okay, how do I know that it is a quadratic equation? It's got a squared in it. It's got x squared in it. So step 1 is to make it all equal to 0. 2x squared minus 8 is equals to 0. Step 2 is to factorize, starting with a common factor. Do I have one? Yes. 2 is taken out and I'm left with x squared minus 4 is equals to 0. Now how do I get rid of that 2? Well, I divide both sides by 2 and then it disappears. It's nice. And now I'm left with x squared minus 4. Okay. Do I have any more common factors? No, I don't. Do I have a difference of 2 squares? Yes, I do. A difference of 2 squares are lovely. Nice and easy, if you remember the rules. And remember to think about things as you write them down, because often people don't think as they write something down, and they write down the wrong number. Have I factorized it completely? Yes, I have. So that means I need to divide the 2 factors up into 2 different equations. And I now have x is equals to 2 or x is equals to negative 2. Nice, easy question. The next question. Okay, 2x squared is equals to minus 5 minus 7. How do I know that it is a quadratic equation? It's got an x squared. So step 1 is to make it all equal to 0. So 2x squared plus 7x plus 5 is equals to 0. I've done step 1. Step 2 is to factorize. Do I have a common factor? No, I don't. Do I have a difference of 2 squares? No, I don't. Do I have a trinomial? Yes, I do. So let's do our calculations on the side. And 2 factors of 2x are going to be, well, 2x squared are going to be 2x and x. And 2 factors of 5 are going to be 5 and 1. There's nothing we can do. It's a prime number, and so is 2, so those are our only options. 2x times by 1 gives us 2x, and 5 times by x gives us 5x. 5x plus 2x gives us 7x, so therefore our brackets are going to be 2x and x plus 1. 2x plus 5, and x plus 1 is equals to 0. So step 2 is done. Step 3 is to divide the 2 parts up and make each one individually equal to 0. Remember, we do this because anything that is multiplied by 0 gives an answer of 0. And that means that x is equals to negative 5 over 2. And for those of you who are wanting to show off, you can then show that you know that negative 5 over 2 is actually negative 2.5. Personally, I like to leave it as negative 5 over 2. And then on this side, x is going to be equal to negative 1. So our 2 answers are x is equals to negative 2.5 or x is equals to negative 1. I'm sure by now your brains are a little tired and you do need a break, chance to stand up. When we return, we will be doing simultaneous equations. We'll see you a little later. Hello grade 10s. I hope you're feeling more relaxed and ready tackle the next section. We're going on to linear simultaneous equations. So we're finished with linear equations and quadratic equations. We're moving on. Now, linear simultaneous equations, you do need to know your linear equations for. So once again, if you're struggling with linear equations, go back and get them right. What makes simultaneous equations different is that you will have two variables that you need to solve for. In other words, two variables means you will need two equations. Let's go and look at some examples. For instance, if I were to write down 2x plus 3 is equals to 5. Am I able to solve for x? Not really. I can't find a value for x, but I can solve it in terms of y. Now what that means is that I will have a y in my answer for x. However, if I were to introduce a different relationship between the two, so I would say, yes, 2x plus 3y does equals 5, but also 2x plus y equals 7. Now I'm able to figure out what x is and what y is by using different algebraic methods. And there are two methods that we're going to focus on. There is solving by elimination, and this is when we literally eliminate one of the variables. So solving by elimination, and then there is solving by substitution. Personally, I prefer solving by substitution because it works with everything. Substitution. So in other words, if you were to get a quadratic simultaneous equation, you'd be able to use substitution as well. It's a little bit more difficult to do it using elimination. Now, solving by elimination is literally when you take the one equation and you either subtract or add the other equation to it. The result you want is for one of the variables to disappear completely. And this example that I've written on the board is a nice example for that reason. One of them will disappear completely if I subtract the two equations. Let's go see how it's done. So I have 2x plus 3y is equals to 5. And 2x plus y is equals to 7. If I subtract the two equations, it means 2x minus 2x is going to give me nothing. And 3y minus y is going to give me plus 2y. And 5 minus 7 is going to give me minus 2, which means that y is going to equal minus 1. So I've eliminated the x by subtracting the two equations, and I've gotten an answer of y is equals to minus 1. How do I find out what x is equals to? Well, I'm going to substitute that value for y into an equation. Because there are so many equations going on here, it's really important that you tell your teacher what you're doing. So you need to say you're substituting y is equals to negative 1 into 2x plus 3y is equals to 5. And that means wherever you see a y in that, you're going to replace it with a negative 1. So there's no longer a y, it's negative 1 is equals to 5. Then you add what you can and you move what you can't. So it becomes plus 3. How did that happen? Well, 3 times negative 1 is negative 3. Take it to the other side, plus 3. 5 plus 3 is 8. X is equals to 8 divided by 2, which is x is equals to 4. Now remember how I said a happy teacher gives more marks? The way you make your teacher happy over here is you write your answers. Therefore, y is equals to negative 1 and x is equals to 4. Just so that your teacher can see your calculations and then see your answers immediately. Now substitution is going to be similar to this. We had the problems 2x plus 3, or the equations, is equals to 5, and 2x plus y is equals to 7. Substitution implies that we're going to substitute one of these equations into the other. But in order to make things a little easier for us to see, I'm going to first start by giving these equations names. And now, being a mathematician, I've got highly original names for them. I've got equation number 1 and I've got equation number 2. There we go. So equation 1 and equation 2. In order for me to substitute one of these equations into the other one, I've got to make either x or y the subject of the formula. In other words, make it either x is equals to something or y is equals to something. In the second equation, it will be easier to do because y is on its own. So the first thing I'm going to write is in 2. In other words, I'm telling my teacher in equation number 2, and let's rearrange it. Y is equals to 7 minus 2x. Is equation 2 the same as this down here? Yes, they are the same, except this one down here, which I'm going to call number 3, is just rearranged. Now, it's solving by substitution, which means I need to substitute number 3 into either number 1 or number 2. If I substitute it into number 2, I will find that it all cancels out. And the reason it happens is because 2 is the same as 3. So you need to substitute 3 into whatever it isn't. So if 3 isn't 1, then you substitute it into 1. So in my next line, I'm going to say substitute 3 into 1. And that means wherever I see a y in number 1, I'm going to replace it with 7 minus 2x. Now, number 1 is 2x plus 3, and then in brackets 7 minus 2x, because that's where the y was, is equals to 5. So where the y was, I've replaced it with 7 minus 2x. I now multiply it out and solve for x. So 2x plus 21 minus 6x is equals to 5. And I have minus 4x on this side. And 5 minus 21 gives me minus 16, which means x is equals to 4. Do I have the answer for y? No, I don't. So now I need to substitute x is equals to 4 into one of my equations. It doesn't matter which one you substitute it in, just make sure it's easy for you. What I generally find is number 3 is the easiest one to substitute in because it's already y is equals to something. So when you substitute x, a value for x in it, it'll work out nicely. So I'm going to substitute it into 3, where y is equals to 7 minus 2 times 4, and let's check quickly that I have written it down correctly. Yes, I have. Multiply it out. Y is equals to 7 minus 8, which means that y is equals to negative 1. Therefore, x is equals to 4 and y is equals to negative 1. We've used two different methods to solve the same problem, and we've got the same answer with both of them. And that shows that you can use both methods. Now, it's entirely up to you which method you use. You can use elimination or you can use substitution. However, if the question says solve by substitution, make sure you follow the instructions and don't do elimination. Make sure that you can do solving by substitution before you go to grade 11 because it will be important in grade 11.